Hi, I wanted to show you the process of actually implementing a set of objects, coming up with a design and implementing it in Java using Eclipse. We're going to do it very quickly, and we'll do the example we started in lectures the other day of a car. So I've written down here what I can remember that we discussed. A car has a speedometer, some wheels, a sunroof, an engine, an accelerator and a brake. From the car, the driver can turn the engine on and off. They can open and close the sunroof. They can check if the sunroof's open. They can check if the engine's running. They can check the speed of the car using the speedometer. They can press or release the brake pedal. They can press or release the accelerator. The driver probably shouldn't press the brake and the accelerator at the same time. We didn't say that yesterday. It's something I just jotted down then when it occurred to me. So this is like a story. This is a rough idea of what a car's like. Let's just look at and we're going to try and model it physically using the objects. So the first thing we do is, using objects, the first thing we do is we try and identify what possible classes we might have in our model. Now we could do the whole thing as a monolithic thing. We could just have a single class called car and it does everything, and that would be the approach in C or something like that. But in OO we're going to want to split it up into lots of little small classes, each with well-defined and fairly small self-contained responsibilities, and the classes will all interact with each other, and this collection of interacting objects will be our model of the car. So what will the classes be that we draw our objects from? Well, the simple trick is you normally just look for the nouns. Concrete nouns give you some good candidate objects. You'll probably get extra objects as well, because there are non-concrete things normally that you're modelling. And not all concrete things deserve to be modelled. Some of them have no interesting responsibilities or relationships. But let's just go through and look at the nouns here. We've got a car, we've got a speedometer, we've got wheels, sunroof, engine, accelerator and brake. And we've also got driver. What other nouns are here? Probably driver's the only other one. And I was thinking we probably wouldn't model the driver. We're just going to model the car. The driver will be the person that uses this whole car interface. So we'll say we'll have a class. Here are our candidates for classes. Our first cut. Maybe we'll have a car. Maybe we'll have a speedometer. On different lines so we can make some notes about them. Normally we do this on little bits of cardboard. We'd write car on the top and speedometer at the top, but hey, we'll do it on the screen here. Wheels. We probably should have separate wheels, but at the moment we'll just regard them as a single unit, the collection of all the wheels. Sunroof, engine, accelerator, brake. Okay, so here are possible, here are our candidates for possible classes. Now I reckon a car, we're going to need that. We're coming up with a car class. Of all these things here, probably the sunroof might not need to be modelled. Maybe we can simplify the design and not model that, because it's sort of independent of everything else, whereas all the other objects you'll see in a second are going to be all linked to each other. So we initially modelled that, and I think we've already done this in class. I think I showed you this in class. We initially modelled that like this. We modelled it with a simple Boolean variable, an attribute of the car class called isOpen. Sunroof is open. IsOpen probably isn't such a good name, is it? Because the door could be open, or the glove box, or something else. And then we simply, when we create a car, we set isOpen to false. So initially the sunroof shut. We give a function called openSunroof and a function called closeSunroof and an interrogation function called sunroof. Open, probably should call that is sunroof open or something like that. Sunroof is open, and it should be named after a predicate. So when you say it in an English sentence, it makes sense. So this is why I'm muttering about the name here. You'd probably want to have it something like, if you said sunroof is open, that would be quite a good name, because then inside your code you could imagine saying if sunroof is open, then blah, 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 blah. So it reads quite nicely. I've got rid of the is, and it's still not too bad in the code. If sunroof open, do this. Sounding a bit more cryptic now, isn't it? But still reasonably clear. I think I'll leave it like that, because that's what we did in class. Okay, so then the next thing we did in the class was we thought, what are the responsibilities of a car? What are the things that a car needs to be able to do? And we can see from this here, they're the sort of verbs, the methods the car might have, the verbs in the story here. what can the driver do? What can the user of the car do? Well, they can turn the engine on and off, so there should probably be a function to turn the engine on and a function to turn the engine off. They can open and close the sunroof. Well, we've already implemented functions to do that. Check if the sunroof's open. We've implemented that already. Check if the engine's running. We'd better do that. Check the speed of the car. Well, it's going to involve the speedometer in some way, but it's going to be something the driver's going to want to do, so it needs to be a car method. Press or release the brake pedal. Yep, the driver can do that, so we'll need functions to do that. Press or release the accelerator. Okay, so that gives us an idea of the sorts of methods that the car may well have, so let's whack them in. Now we might say we've got open sunroof, sunroof is open, closed sunroof, so we probably want, what were the other ones? How will I do this? I'll try and do it so we've got both on the screen at the same time. Is that going to be possible? So open, close. Next is check if the engine is running. Okay, so that'll be public boolean I'll just say is running, car is running. If that becomes unclear later on, we'll better rewrite that to be we'd rewrite that to have a longer name, but at the moment the only thing that can be running is the engine. Okay, I'm a bit itchy because we're going to have a problem in this example because we're not going to really give the car much actual functionality, and the way I'd like you to write code and the way I want to write us all to write code in this course is to write our tests first. So really I should start writing some tests before I write any code. It's going to turn out to be hard to test the car, but anyway, let's do the best we can. So let's open test car, which we already wrote for. You've seen that already. All right, let's do something like when the car starts, we're going to assume that the engine's not running. So we'll assert not is, what's a car called? We called it Optus Prime. It's a fairly odd name for a car. Let's just change that. It was probably a joke at the time. So I'm changing that using the refactor method here, refactor, rename, and that'll change it everywhere, which is really convenient. So we won't call it Optus Prime, we'll call it car. What do we call our car? It could be, I can't think of a funny name for a car, we'll just call it a bug. Okay, so if it is not the case that the bug is running, then we're happy because we don't want a new car, regardless of whether the roof is open or not, to be running when we first get it. And then we probably want to be able to start the car. So bug dot turn on. That's turning on the engine. And then we're going to, so now that it is running, hopefully it's a start first time car. And then we're going to turn it off. I should just copy those two lines at the same time. And we're going to check that it's not running. Again. Test. So turn on, so that it is running. Turn it off, and so that it's not running. Okay, then we're going to compile it, and of course Eclipse will grumble, as you can see, because we haven't implemented all these methods yet, so we'll just let Eclipse do that for us. Please implement turn on. Thank you. And please implement turn off. Oh, that looks good. And now let's run our test. It's got compiler errors, so it's going to grumble a bit. Unresolved compilation problem. Something didn't return Boolean. What didn't return Boolean? Car is running. Oh, is running doesn't return Boolean. What did I do? I didn't give it the right time. Oh, I didn't give it a return value. So let's return. Actually, we'll return true. It's a pretty hopeless function, isn't it? Because the engine's always running, so we're going to fail our very first test. Let's compile again, which is when the car starts. When we buy the car, it shouldn't be running. And lo and behold, we're going to fail that. It is running initially. All right, so we haven't put all the functionality in, but we've sort of got the skeleton in there. Now, let's think. How are we going to implement is running? Well, how are we going to make the car, how are we going to implement turn on the car? We're going to look at the elements of the car here, and we're going to see that, let's see. The car, I'm going to have to implement the engine, aren't I? I can't make the car run without an engine. So, all right, let's whack in the components of the car now. The car has an engine, and if the car has something, that means something belongs to the car, it's a part of the car, I'd better store it in the car itself. It's private because of abstraction. I don't expect the driver to interact with the engine directly. It's just for us. So private engine, the car has an engine, and I'll just call it engine. Upper and lowercase letters, that's absolutely fine. In Java, we sort of do that all the time. In other languages that would be bad, but because we're so case obsessed with class names here, we don't mix up classes with instance variables. So we've made an engine, and what else? We might as well give it all the other things it has. It has a speedo, and it has some wheels, a set of wheels, and it has sunroof. We've already done that with the boolean. It's got an engine. We've done that. Accelerator. And it has a brake. Okay, now we've typed in all our classes. We've said these classes exist. Of course they don't, and that's what these little things on the side are telling us here. They're saying my class, the class you're referring to, doesn't exist. I've just got my RSI thing popping up here. I might just kill that. I can work out how to do that. Where are you, RSI thing? Oh, I don't know how to turn it off. I'll go down the bottom. It's hiding. Oh, here it is. It's not hiding at all. Okay, let's create them one at a time. Please make a class called engine. And we'll call it engine, and there's really nothing else to say. Please make a class called speedometer. Please make a class called wheels. Please make a class called accelerator. Please make a class called, oh, what happened here? It's not a capital letter. Well, our classes don't start with capital letters. Brake. There we go, now we've made all our classes. Now the only one we need at the moment is the engine. So our car has all these things. Notice at the moment it has them in the sense that it has a reference to them, a private reference to each of these things. Nothing's actually been allocated or created yet. Okay, let's look at what an engine has to do. Well, let's implement start. I guess that'll tell us what the engine has to do. Where's turn on? Okay, turn on. How do we turn on the car? I guess we tell the engine to start. So we'd go engine.start. And I guess turn off is going to be engine.stop. And I was just thinking of something fancy. We'll do that in a sec. Let's engine needs these methods. We haven't given them to it yet, so let's whack them in. Right. Now let's run our code and see how we're going. Hello from car. Yes, that's all car does. That's the main method of car. It just prints hello from car. See up here. Let's go to our test. Let's test car. Test car. And we've still got an exception here, which is what? Yes, initially the car seems to still be running, so we'd better check that. How does his running work? is running always returns true. No, well, it shouldn't always return true. It should return whether the engine is running. Car.running is true if the engine is running. Looking good. We've got a bit of a grumble here. What's that? Is running is undefined for the type engine. Create it then. And now engine has a start, a stop, and it is running. It always returns false. So that engine doesn't have a main method, so we better tell it to run that test car main method. Run. Okay, now we've got another problem. We're running our code and we've got a null pointer exception. At null pointer means we're trying to dereference a null pointer. It's, as you can imagine, a bad thing. Line 24 of car, let's have a look. Engine is running. Where are we trying to dereference a pointer there? Well, actually, the whole thing is dereferencing a pointer. We're saying, give me the engine of the car and call its isRunning method. But what's the engine of the car? Well, at the moment, the engine of the car is up here. It's a reference to an engine object, an object of the engine class, but we never created one. So it's it starts off, it's initialized to be null. Engine is null. So that's null.isRunning. Can't dereference null. That's crazy. So we better create an engine. So when we create the car, we better go this.engine. Start engine equals new engine. Now we've got an actual engine. That'll build an engine when we build the car. And now let's run the test. And we've got an assertion error on line 18. So we created the engine, we turned on the engine, and then we asked, is it running now? And it's not. And that's because at the moment the engine is still a stub class. It always just claims to be not running. And if it is, so here we'd better do that same thing we did before, which is create something to store the state of the engine. Is running. And when we create the object to start with, where is the constructor? Oh, we don't have a constructor. Better give it a constructor. So that's engine public engine, no arguments. Engine is running equals false. New engine, so the engine off to start with. And how do we start it? Well, easy enough. We just say start is running. Oops. I'm just trying to hit control space there. I hit the wrong key. Control space will fill that in. With a sensible suggestion. Yep, this dot is running equals, what am I starting at? So it's true. And put that down here. It's false. All right, now, so we actually get a bit of sense about what's happening here. I'm going to say that whenever you start the engine, it makes a sound. And let's print that out, just so we can start to trace what's going on when we start things. So let's say when you start the engine, what sound does it make? Okay, I suppose that's the sound it makes. And when you stop the engine, what does it say? Well, maybe adjust this quiet. Silence. So let's see, we started it, we turned on the car, testing, where did testing come from? Let's find where the testing came from. Oh, testing car, oh I see, testing car, test car, prints that out to start with. So that's us turning the engine on, and then clunk, we got an exception, line 18 before we got to turn it off. Is it running? That's not working. Oh, did we not? But is running, but we're always returning false. So we'd better return. Oh, now I've got my isRunning function has the same name as the isRunning variable. That's not good, is it? Let me refactor that. That's confusing. What's a better name? Instead of isRunning, is turning over. That's what you call an engine. You say, is it turning over? That, I'm sure I've heard people say that before. Is turning over. Yeah, that's better. Okay, it's just checking that that's all the changes I want to make, and they are. So that's right. So return is turning over. All right, so our tests turn on the engine, we test a couple of assertions, then we turn it off, silence. Oh, now we get a last. Oh, when we turned it off, it didn't work, and I've just noticed why. It should be false, or false, as I like to call it. So now when we turn this engine off, it will actually turn off. Okay, so a very, very naive test here. It's very simple. Simply opens and closes the sunroof, which doesn't make any sound. I think that should make a sound, don't you? Let's go back to the car. When you open the sunroof, what sound does opening a sunroof make? Like a zzz. How do you spell that? It makes a click. Click. Click is the sound it makes when it opens, I'm pretty sure, and to shut it goes. Oh, I reckon it makes sort of the same sound when you shut it. Maybe it goes clock. Right. So now let's see, we've got someone unhappy here. Oh yes, the little red things are there because I forgot to put the semicolons in. Thank you. Oops, for reminding me of that. That's right. Hello from car. All right, the car compiles at least. Now let's compile and run test car. Let's open it. Click. We open the sunroof and we do some tests. Clock. What's that? It's turning on the engine, and then click. We're turning it off. All right, fantastic, perfect. Let's take a little break now, and we'll return in a sec to look at how we make all the different components of the engine interact with each other, as well as just interacting with the engine, with the car itself.